Hello, everybody, and welcome again to ODSC West. Thank you for joining us. My name is Bob Foreman. I'm the Senior Software Engineer at LexisNexis Risk Solutions. With me is Hugo Watanuki, who will be my silent partner in this presentation, although later on in this afternoon, we'll have a 3-hour workshop where Hugo and I will both be talking, sharing code and information about HPCC systems. This is a short talk on what is HPCC systems, the kit and caboodle for big data and data science. Now, in a nutshell, here's what we want to do in the 20 minutes we have together. I just want to let you know that HPCC systems is open source, completely free. It's very easy to use, less coding is involved, and our goal is to aim HPCC systems to be your one-stop shop for anything that you need to do with big data, data integration, any querying of data, or analytical needs like machine learning. So how did HPCC systems get started? Well, we solved a problem for one of our clients, and then we said that that problem was so dynamic that we decided to use it for our own big data problems that we had internally. And the intention of the platform was not to sell it to anybody else. As a matter of fact, we have had this platform up and running and proven for nearly 20 years now. So we used it to solve our own data problems and to run our own business at LexisNexis. If this wasn't a virtual conference, I'd be sitting at our table and you would walk up to the HPCC systems booth, and the most common question I would get is, what is HPCC? And I tell everybody HPCC stands for High Performance Computing Cluster, but also in 4 words, I describe it as a distributed data parallel processing platform. So we have the best software behind HPCC systems to give us distributed data, parallel processing to be not only fast, but also very accurate. And of course, here's a slide that says that we're just about everywhere in business. Any business that deals with big data, which is just about anything nowadays, everything from autonomous vehicles to, well, in factories, we have an HPCC system that works with smart hard hats, a company called Guard Hat. All over government and, of course, businesses, public records, insurance, healthcare, financial services, banking, and so on. This is a processing platform that is all across all verticals. Here's a quick timeline of HPCC. Like I said, we started back in 2000. We've been going for about 20 years now. In 2011, we made this choice to go open source. The reason was we wanted to be relevant to the community. We wanted to expose our technology to the community, have them contribute, and also give us ideas on how we can improve our platform. We listened to you. Between 2012 and 2016, most of the requests that we received was, how do we make our platform easier to use for people coming in from other platforms and other languages like R, Java, Python, and other platforms like Hadoop and Spark. So we developed connectors and plugins to allow you to easily get up to speed with HPCC systems. And if you have algorithms written in other languages, you can easily drop them into ECL. You don't have to learn ECL and HPCC systems overnight. Over the last few years, what have we been doing? Well, again, improved processing architecture, improvements on moving. We are already in the cloud. As a matter of fact, the training cluster you'll be working with later on this afternoon is already an AWS cloud cluster, but we also have cloud initiatives in other platforms that I'm going to talk about. We improved our IoT, Internet of Things, of course, and then we also have more bundles and machine learning expansion in the last few years. Now, the whole idea behind HPCC is pretty simple. Back in the old days when we had a single entity of data, there was always inaccuracies built into that data set. So we discovered that by combining different data sets together, linking them, cleaning them, profiling them, we then result in a more actionable, smart data set that then the customer has more value. Now, HPCC systems can run on a single laptop or desktop. You can kick the tires very quickly and easily in about 10 minutes. Start your own HPCC cluster, or for real, for working with big data and real business solutions, we have server farms working together as a single processing entity to transform and deliver your big data. On the left side here, you see the Oracle VirtualBox open source product. You install that, then you install the HPCC VM machine, and your laptop or desktop can become a single node Thor, single node ROXIE HPCC cluster. On the right side here, we have hard metal clusters, we have data centers all over the United States, and also we have cloud. We have built-in AWS, and we also have a solution for Azure and Kubernetes, building HPCC systems on those platforms. And again, this slide right here just shows you bringing in big data from the outside world, dividing into smaller pieces on each computer, each node, dividing the job, computing it to give us and then a correlated or collated result. This diagram right here just shows you big data coming in from the left side. We have two clusters with HPCC systems. One is called Thor, which is our data refinery or data factory. The other one is called ROXIE, which is our data delivery cluster. The underlying language behind it is called ECL. ECL has built in all kinds of other libraries that come with ECL, like machine learning libraries, data management libraries. And then to the right, we have the delivery through ROXIE so that the customers can query the data, visualize the data, and also connect to the data as needed. Also in the lower left-hand corner, you see the developer platforms that are available, the ECL IDE, VS Code, Cloud IDE, and also our command line interface. Now the open source stack solution, Thor, again, our data refinery, ROXIE, our data delivery engine, built into HPCC systems, is our data management tools where we have profiling, cleansing, consolidation, scheduling, the whole Kaboodle, like I like to say. And then machine learning libraries, everything from the low-hanging fruit like linear regression and logistic regression, all the way up to GNN and DBScan and a lot of others that we're going to be looking at. This diagram right here just shows you the whole process, what we also like to call the data lake, moving in data from multiple types and then moving it into our data lake, churning that lake, wrangling it, pulling out the water that we want, that individual glass of water to the consumer, information delivery. Our clusters are scalable, many petabytes of data we can hold, runs on commodity hardware, so it's very cost effective and it's very fast, very accurate. Here's a quick diagram of Thor and how it works and what its job is. Thor profiles your data, cleans the data, transforms the data, and then performs analytics on it. So we manage data more quickly and efficiently. In ROXIE, it's a simple data delivery engine. We send to ROXIE pre-compiled queries that are also running concurrently through a number of interfaces, options available, JSON, representational state transfer, SQL, XML, and so on, HTML, which is not shown here. And we can deliver queries at sub-second response times to thousands of users, up to 15,000 queries per second on a typical production ROXIE. Behind all of it is ECL. ECL is the language that runs Thor, runs ROXIE, works with your data. It is a declarative language, and the idea behind ECL is not how to do it, but what data do you want? So you simply declare to ECL, this is the data set that I want, this is the filter on the data set that I want, this is how I might want to transform it, this is how I want to join it, and then the compiler optimizes your code, compiles it down to C++, which then compiles it down to a shared object file and a DLL, and we're off and running. It's transparent, implicitly parallel, optimized, a data-centric language. Any type of data you want to throw at us, we're going to handle it. And I think the syntax is pretty intuitive. I think it's pretty easy to read and understand with just a few sessions, a few lessons of learning ECL. Hopefully by the end of the workshop today, you'll have a good familiarity of ECL and be able to start writing some of your own queries and examining some of your own data. Well, we have a lot of different integrated development environments that you can use to work with ECL. The first one that's most popular to me is the ECL IDE. This is a Windows platform using the .NET framework. You see on the left-hand side here, you have a data repository. You have your workspace for your ECL language. You have all kinds of options and bells and whistles. You get instant results in your builder window in your ECL IDE environment directly. And so this has been around for over 15 years, well established, very solid. 95% of our users use the ECL IDE. If you want to go to the dark side, well, we have Visual Studio Code with the ECL extension. So those of you using Java, Python, R, other languages in Visual Studio Code, and you want to start to integrate ECL with those languages, a lot of people, and of course you might have a Mac laptop. Of course, the ECL IDE doesn't run well on a Mac unless you're using a Windows virtual machine. So a lot of people like to opt for using Visual Studio as their option if they have a Mac OS. And also, if you don't like integrated development environments, we do have a command line interface too. We have the ECL executable, which allows you to run any ECL command using the command line interface. So the ECL IDE allows you to look at queries, build definitions, reuse those definitions. Also with the ECL IDE, we have the ECL Watch. This is a web service which actually shows you your cluster. It shows you what clusters are installed, what clusters might be running at a particular time. You have a built-in event scheduler to schedule jobs at any given time or event. There's a great search engine to search for files and work units and so on. This is the ECL Watch that's automatically built into your HPCC systems. Any browser will run the ECL Watch, and you can look at all kinds of things like active ECL work units. You can look at cluster activity. You can browse through previous submitted work units, searching through files to get record counts, layouts, sample records in the ECL Watch, status of the servers. Very important. You can look at log files of particular jobs. And finally, if a job is running maybe too long, or maybe you want to stop it for some reason, you can actually stop and start your processes directly from the ECL Watch service. All right, so this slide right here says, how do I get started with an HPCC cluster? I want to get data from the outside world into my cluster on the right side. So on the left side, we have this thing called a landing zone. And the files that are on the landing zone can be in any file format that's available. Anything that you have on the landing zone can be moved over to the cluster in one of these 5 formats: fixed length files, delimited files or variable length record files, IBM format files, they call those variable files, XML, of course, JSON. Now we have 3 different ways to move data from the outside world to the cluster: the ECL Watch, using an ECL work unit with a built-in library, and also you can use a command line interface to perform this spray operation. What does spraying do? It takes that single file on the landing zone, it moves it in physical parts to every node on your cluster, divides the large file into smaller physical parts on the cluster. Then node number 1 works with part 1, and node number 2 can work with part 2, and so on. And the beautiful thing is, as an ECL developer, you only reference the file as a single logical file name. So you could be on a 100-node cluster, a 50-node cluster, a 10-node cluster, it doesn't matter. You reference your data set as a single file name. All right, here's another picture of the HPCC cluster and how we deal with extract, transformation, and load. Once again, big data comes in from the left. The data is profiled and cleansed, it's standardized, it's related, and then linked together, analyzed together, and then this sweet spot at the far right side is when we deliver the clean data over to ROXIE, and then the outside world, the consumers, then query the data in a variety of different ways using batch services, real-time services, and visualization and integration. All right, to wrap this up, we're going to show you some of the other caboodle of HPCC systems, the built-in plugins and libraries. One of the things we're really excited about is the integrated data profiling that's built in the HPCC. Every file has an ability through the ECL Watch to be analyzed. And this analysis gives us a very detailed report on the data, giving us things like fill rates, cardinality, numerical ranges, quartiles, textual patterns of individual fields, maximum recommended lengths, and so on. It's so, by the way, it's so powerful that not only can you do it in the ECL Watch, you can also call it through one of our bundles, and you can also call it directly through our standard library function. All right, you like machine learning? I do. Look at ECL and what we do with machine learning. We have bundles that are available. Once again, automatically open source. You can download these bundles and work with machine learning written in ECL and apply to your data sets through HPCC. Everything from the unsupervised learning like dbScan and k-means, supervised learning, of course, logistic regression, classification forest, support vector machines, neural nets. We have things like GNN, RNN, working on perceptrons, ensemble methods like random forest, and we just released another version of our gradient boosted forest and gradient boosted trees. Now, ECL is in the center of everything. We have all kinds of modules that are associated with ECL. There are machine learning bundles, visualization bundles, database connectivity to MySQL, and also web services SQL, where you can enter SQL statements and return the ECL equivalent. And then a variety of different text processing modules like trigram, prefix tree, and web log analytic modules. Let's look at plugins. Look at the plugins that we have available. Java embeds, you have SQLite embeds, Cassandra embeds, R embeds, Python embeds, PyEmbed, Memcached and Redis, which is our in-memory data sets that you can work with, Kafka, NLP++, a new extension to our natural language processing support that we are going to be talking about in our upcoming workshop. And so this is kind of a summary list of everything that we have available. Built-in auditing, logging, Metaphone, again, interface with Kafka, Security Manager, interface, Redis, Memcached, Spark connector. You can also use the Eclipse IDE to connect and run ECL. Data integration plugin for Pentaho, R integration. Of course, we already talked about the Visual Studio Code extension, the JDBC driver, a Java API, ODBC driver. And here is the link that you can go to view all these plugins and download them. There is a very comprehensive README file on each one of these, and a lot of them have some very great examples that you can use. All right, so embedded languages. C++ was always there since day one, but you can embed R, you can embed Couchbase, you can embed Java, you can embed JavaScript, MySQL, Python, SQLite, Cassandra, and AWS Simple Queue Service. And here's the links to all of this information on this slide. By the way, these slides are available. I'm going to show you the link. We have a GitHub repo of this presentation, our workshop presentation, and a number of different code examples. So just about wrapping up here, we have our embedded language plugins. Here's like an example for Python. And this is all ECL code that you're looking at. The trick here is this statement called embed, and you just simply tell ECL that you're going to embed some Python or natural language toolkit or Java or MySQL. It's that simple, using an embed, using ECL. And that brings us to our close. So the kit and caboodle of HPCC systems, what I was trying to show you in just this brief time that we had together is we want to be a one-stop solution for your big data needs. We've been around for 20 years, although we're going to have our 10th anniversary for open source coming up next year, next June. And LexisNexis relies its business on a lot of our solutions that we have in HPCC systems. So it's a versatile platform. We want you to take a look at it. We have a workshop coming up. I believe it's at 2 o'clock Pacific Daylight Time. Hugo and I will both be presenting that, a 3-hour workshop, and we're going to dive deep into ECL, show you how it works. We're going to be talking about natural language processing and machine learning and some fundamentals of built-in visualization of ECL. I'm going to go ahead and stop right now. And here, I'm going to leave this slide up here for everybody. This is the link to our workshop where you can get the class materials for our upcoming workshop. And at the bottom of this slide, you have 2 clusters that are up and running. So you can go out to those links and actually take a look at a running HPCC systems cluster, take a look at some ECL languages out there. And that link at the bottom will be the one that we'll be using in our ECL workshop that will be coming up very soon at 5 o'clock Eastern time and 2 o'clock Pacific Daylight Time. That's my talk, that's my presentation. It's been a pleasure. Thank you for stopping by and listening. And I will open the floor to questions. Over to you, Hugo, if you can hear me.
Yep, thank you so much, Bob, and congratulations for such a comprehensive demo talk. So now we are open for questions, and I would like to remind you all, you can post your questions directly on the Slack channel, which has been provided on the chat window of this demo talk session. Or if you can raise your hand, I can also capture the question directly with you. Yeah. While we are waiting, Bob, so far there has been no questions, but I think one of the items I wanted to highlight, even though it was frequently covered on this presentation, is that even though it's a very comprehensive platform, it's your one-stop shop for any big data needs, it is very accessible. You don't need to have a dedicated infrastructure or a very large and complex data center to run HPCC, even though you might try to associate that with such a comprehensive big data platform. So if you want to try it, just for curiosity, remember that we have those 2 clusters up and running on the addresses displayed on the bottom of the slide on this screen. And the first address, the playhpccsystems.com, is actually up and running 24/7 in the internet. So even if you cannot, for some reason, give it a try today, or if you cannot join your workshop for any reason, remember to download the class material and give it a try later, okay? If you want to run the platform locally on your own PC, there will be also instructions guiding you how to deploy a one node cluster on your PC, so you can at least get familiar with the platform and with the programming language.